Alright, so by request, we're going to do a quick little video on graphing linear equalities, section 7.3 in your book. So basically what you're looking at is 4 different inequalities that are different types of lines that are going to show up on our graph. So I'm going to try to color code it. The first one is going to be in green, and we can remember with y equals mx plus b, the 2 is the y-intercept, and the 3 is the slope, which is rise over run. So I'm going to put a dot at 2, which is the y-intercept, go up 3 over 1, down 3, left 1, and so on. And then I'm going to connect that with a solid green line. Now, the reason it's solid is because it was equal to, it included the equal sign under the inequality. And because it says y is greater than the line, that means I have to shade everything above this line. And like I said, it's solid because of the inclusion of the line. So it's everything up to that line and including it. Now, in red, this is a nicer one. It's just at x equals -10, which is a vertical line straight up and down. This time I'm doing it dotted because it's only x is greater than, and it doesn't include the equals on the bottom. To say that something is greater than -10, in this case, it means I'm going to the right. So I'm going to shade everything over to the right. Now, for the third one, I'm going to do it in blue, and it says y is less than or equal to 7. So I have to draw a horizontal line along y equals 7. And because it says less than or equal to, I put a solid line, and I shade below that line, including the line itself. So notice it's not dotted this time. And the last one we'll do in purple. It's the hardest one. We have to rearrange it a little bit. Usually it's best to put it into a slope-intercept form. Notice what happens if I divide by -3, I have to reverse my inequality sign. So anytime you multiply or divide by a negative, your inequality will reverse which direction it's facing. So what that does is it gives me a y-intercept of -5. The slope is -5 over 3. And because now it says y is greater than, I have to shade above this purple line. And it is a dotted line because it doesn't include any equals. It's just greater than, not greater than or equal to. So now, and I put it all together, if I'm above that purple line, I knew I was below the blue line, to the right of the red line, and above the green line. So it turns out that the red line almost didn't seem to matter in a sense, because my region ends up being in between the other 3 anyway. I'm going to shade it in gray, and that's my final solution region, is that little triangle in between the blue, purple, and green lines. To figure out if I did this correctly or not, one way to check is to pick a point inside the region as a test point. So I'm going to choose as a test point -2, 3. So -2, 3 should work. So that means if x is -2, and I plug it into the first inequality there, and y is 3, it should be a true statement. So at the end of it, I see 3 is greater than or equal to -3, so the first one works. You technically should check it for each one. Double check that your x value is bigger than -10 and so on, that your y value is less than or equal to 7. And for the purple one, I'm going to plug in the x's and y's, and it turns out, yes, 1 is less than 15, which means our region looks good. Thanks for watching.